Recording and sharing. All right. Can everybody see the week 2 meet session up?
Yes.
Excellent. Okay. Before we jump into the material for this week, the little mini lecture, are there any questions about last week? Any questions about the assignments, that I sent back, my feedback, any of that kind of stuff that you guys want to ask really quick? Okay, fantastic.
I don't have a question. I do have a comment, though.
Sure.
The feedback was really, really helpful. So thank you.
Oh, you're welcome. I sometimes students have trouble seeing the feedback, so I'm glad to hear that you're finding it okay. And that's how I plan to always give feedback in this class is through the speed grader. Unless you submit something early and I give you feedback through track changes in a Word document. If you have to submit something officially as either a Word or a PDF, then I'll use speed grader where I can cross things out and put a note in, or I can put a little flag and put a note in, and those kinds of things. And those usually seem to work really well for students. Okay, let's jump into our week 2 session. As I said, I've graded everything, and that's what I try to do every week. Monday is my hell day, where I grade all of my stuff. All the classes I'm teaching end on Sunday, so Monday I grade everything, and I try to get it done unless something else is happening. At the latest, you'll ever see stuff graded by Tuesday. And then, of course, if you hand things in late, no guarantee that it won't get graded until the following Monday, but I'll try and grade it early if that happens. Data sets from the textbook, I've mentioned this before, that they're in our Google folder, so go grab them there. It's a lot easier than trying to get them out of the textbook and things like that. This week we're doing measures of center, and of course I have several videos linked in the classroom, just in case you haven't seen that yet. If you go, to the modules, and in module 2, the unit 2 preparation page talks about basically what you're supposed to learn this week. And then down below, I have all of my videos linked here that bring you through all of the various statistical elements that we're going. Now, obviously, none of these videos are going to be doing SAS. These are just the lecture type of stuff where it'll teach you about measures of center, it'll teach you about measures of relative standing, and so on and so forth. And then if you want some help with the SAS stuff, then you have some SAS videos and then some Excel videos, even some R videos, right? These were all done by other people that are included. The university puts those in, and then I add my own at the top. So that's kind of what will happen each week, is you'll see that same thing where you'll have my videos, SAS videos, Excel videos, and R videos. Depending on the week and the materials, there might be more or less of each. And I think some weeks they don't even have any of the R stuff, but I don't think anybody really doing R, so that's fine. But anyhow, back to the theory stuff. The first kind of major concept we learned this week is, what does it mean to be in the middle of your data set? And there are really 3 measures of center, things that we call measures of center, i.e. measuring the center of your data. There's the mean, or what we all know as the average. There's the median, which is literally the middle of your data. Like the median is the thing that runs down the middle of the highway that you slam into at 3 o'clock in the morning because you fell asleep. That's the median. Well, the median also runs right down the middle of your data, but obviously you have to first put your data in, order. It has to go in ascending order from smallest to biggest. Otherwise, the middle could be anywhere, right? It just becomes arbitrary. So once you order your data, you find the literal middle where half your data is above that point and half your data is below your point, and that's the median. And then, of course, the mode. If you haven't heard of that you can think of, if to remember it, as mode sounds like most, and it's just the most frequent data value or values. You can have more than one mode. And there's some great coding options in our SAS how-to document that will help you find multiple modes when they exist in a data set. Because if you just run the plain old summary statistics menu driven option in SAS and ask it to compute a mode, it will give you just the first mode it finds, the smallest mode. So if there are multiple modes in your data set, it will just give you the smallest one, and it won't give you any indication that there are more modes. And Excel is the same way. If you try and get multiple modes out of Excel with just the regular mode function, it won't work. You have to use I think it's mode.multi, and then it'll find multiple modes in Excel that way. And then I'm not sure how to do it in R. Like I said, I don't know R very well, but I can show you those examples later tonight or on Thursday. But just keep in mind that that's what those are, and that getting them out of technology, mean and median are very easy to get out of technology. There's never any problem with those, but the mode, you will get it wrong, right? You'll get the wrong answer presented to you out of technology unless you tell it to look for multiple modes. Now, of course, if your data set doesn't have multiple modes, then you're safe. And if your data set doesn't have a mode at all, you're also fairly safe. Excel, I think, just presents like a dash or an N-A, and I think if I remember correctly, so does SAS. It gives you an NA or something like that, basically saying not applicable, meaning there is no mode. Okay, so let's talk about the middle of these data sets as far as the median and the mode is concerned. I mean, the mean, we all know what the mean is. We would add all these things up. We would divide by how many things there are, and we'd calculate that. That's easy. The median visually, right? You go, okay, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 9 numbers. So whenever there's 9 of them, the median is going to land right on a number, right? So you can see it's going to be 1, 2, 3, 4, the 5th number. The second 7 is going to be your actual median, because then there's going to be 4 numbers below it and 4 numbers above it. Then if we come down here and we have this set of numbers, which is an even set, right? So this is an odd set and the median landed on a number. When we have an even number of numbers, it's going to land in between 2, because if we have 6, sorry, in this case we have 2, 4, 6, we have 8. It's going to land right here in between the 7 and the 8. Excuse me, I've got something. Tickle in my throat. Okay, so it lands in between the 7 and the 8. And then what you do is you just average those two numbers, and you repeat, you report, sorry, the median is 7.5. Questions on those two examples? All right, so it doesn't matter how big or small your data set is. The theory is always the same. It's always in between two numbers when you have an even set of data points, lands on the number when you have an odd set of data points. And like I said, if you run it in any kind of technology, it gives you the correct answer. So you don't have to worry about what's reported as a median out of technology. It's really only the mode. Before we move on, what's the mode of data set, mode or modes of data set A? Catherine?
8.
Yes. Very good. 8.
8.
Yep. Excellent. You can just yell out, Catherine. You don't have to put your hand up. What about data set B? What's the mode or modes there?
All of them.
Ah, that's a great guess. Yep. Oh, look at that. Mo got it right. So did Thaddeus. There is no mode in that data set. And I put this one in here specifically because it will catch people. You know, the whole thing about teaching is you want to find those places of misconceptions. This is a point of misconception for many students. So I put an example there to point that out, because we learn from our mistakes. Everybody looks at that and go, oh, they all showed up twice, so they're the mode. No, remember, the mode has to be the most frequent. If they all show up twice, they all have equal frequency. Nothing is more frequent than anything else, ergo no mode. And if I would have given you the data set that was just 6, 7, 8, and 9, they all showed up once, you all would have said no mode, right? But when you show them all showed up twice, all of a sudden people start to think there's multiple modes. When is there multiple modes? Well, I will show you an example of that, Mary. Here's one way of coming up with frequency distributions. Before, I thought I had more data sets. Let me just change this one. Let's go. Oh, I did change it. Here we go. Somehow it went twice. All right, so data set C has multiple modes. Can you see how data set C would have the modes 6, 7, 8, and 9? Because they all have a frequency of 2, and 5 has a frequency of 1. So because we have that one little 5 in there, it all of a sudden makes the others modes. So that's when you would get a multiple mode situation. Now, in a real world situation, when you have a large set of data, you normally only have a single mode, or if you have multiple modes, it's usually only 2. These are, these are learning tools. So these are visual aids for people just to understand what it means to have modes. But in the real world, unless you're dealing with this kind of data, like if you went out and asked people a question like, how many times a week do you eat out, before the pandemic, obviously, you would get answers between 0 and 7. And then you would have a crap ton of each number, right? You'd have a bunch of zeros, ones, all the way through sevens. So it's very likely that you could have multiple modes. Like 3, 4, and 5 could all come up with equal frequency, that kind of thing. It just depends on the kind of data set you're gathering. And then, of course, with data set D, we're back to that same example where there is no mode. Okay, questions on medians or modes? All right. So frequency distributions are literally just a table where you list the data values and then you list their frequencies. There's nothing more to it. It's just that simple. This is showing how you would come up with frequencies by hand. It's the thing where you count up how many numbers you have between 20 and 30, and you put a little tick marks, or what they call tally marks, right? Until you get how many you have total, and then between 30 and 40, and so on and so forth. Now, who can tell me what is terribly wrong or misleading or bad or whatever with the classes here?
The repeating number of the end that starts the second line. So the 30
Exactly. Very good. When they just have 20-30 and 30-40, if you have the number 30, where the hell does it go? Right? It's not obvious from the description where 30 would go. So what you would normally do is you would say 20, like you would say 20 and then less than 30, and then 30 less than 40. So you would know that the 30 would go in the second class, because you want everything from 20 up to, but not including 30, that kind of thing. Yes, or some of you are saying 20 to 29 and 30 to 39. Thaddeus, that would work perfectly, but only if we had discrete data, right? So if we were counting things, that's what it means to be discrete data. And so therefore your answers were always whole numbers, then yes, you could do that. But what if we were measuring things where we could get decimals and we could get 29.5, right? And 29.9 and 29.999 and things like that? Then you have to show a range, and you just have to be more specific with how the ranges work. Okay, so just keep that in mind, that we want to be clear and concise and precise with our language when we're dealing with statistics. Yes, very good, Kenya. That's exactly perfect. If you wanted to put in an X and show that X is greater than or equal to 20 and less than 30, would be perfect. You could also do something like this, where you could just do oops, wrong one. This one. Although not a lot of people would understand those symbols, right? You got to kind of remember back to the last time you had algebra. For some of you, it could have been a decade or more ago. And remember that the square bracket means including the endpoint, and the round bracket means not including the endpoint. So inclusive and exclusive. So the second one I put in basically means the exact same thing as what Kenya put into the chat window, that we're including 20, but we're not including 30. So there's different ways of doing it. I would say if you had this kind of data and you had to do this kind of display in your dissertation, I would probably go with Kenya's usage, because that's more widely understood. If you wanted to use mine because maybe you had a really wide table and you needed to keep that one thing a little narrower to make it fit on the page, then underneath the table you would just want to put a little note and tell the reader what these symbols mean, because you always have to assume, you basically have to appeal to the lowest common denominator. You have to assume that there's going to be people out there reading your dissertation that know nothing about mathematics, right? And they would have no idea, or maybe they learned it but forgot it, what those things mean. So just keep those kinds of things in mind. Okay, cross tabulations is just a frequency table where your data is categorized two different ways. Thus the cross part of cross tabulation. And tabulations is, you tabulate something, you count it up, right? So it's like cross counting. That's what cross tabulations means. It's how many totals you have across two categories. So in the case of this, the vertical category is where they lived, either off campus or on campus. And then the horizontal category, right, the rows, are their class ranks. So we can see that we had 37 freshmen who lived off campus, and then 100 freshmen who lived on campus. And then, of course, we had a total of 137 freshmen. So the nice thing about the cross tabulations table is it basically just shows you how many things are in all these different groups. And then, of course, this only works if you have what are called mutually exclusive groups, right? So you have to, whatever your categories are, in this case, class rank versus where do you live, there can't be overlap. You can't have people that could both live off campus and on campus. It has to be an either or situation. It can't be a both kind of thing. And then the same thing with class ranks, right? You're either one or the other. There's no overlap. Now, you'll notice that up here, I put you make these in the mini project. So pay attention, folks. This is one of the things that you are required to do in your mini project. So does anybody have any questions about how this works and what it means? Okay, and I will point out something that you need to understand for the mini project. Is you only do cross tabulations on qualitative data, frequency counts. So you wouldn't do a cross tabulation with like age or weight or height. Those are quantitative, right? Those are quantities. They're either measured or counted. If you ask people how many children do they have, that would still be a quantitative variable. It would be a discrete quantitative variable, but you would not do a cross tabulation with that. You only do cross tabulations with what are called qualitative data, a quality, which is data that just describes something, right? Your class rank, freshman, sophomore, junior, senior, right? These are words that they're just descriptors. You can then count up, you can do frequency counts, and that's really all you can ever do with qualitative data is do frequency counts. You can, if you have a variable that the answer to the question, right, or the data that goes into that variable is qualitative in nature, then the only thing you can do with that data literally is to do frequency counts. You can just count up how many you have of each of the options for that variable. So for instance, the variable class rank had 4 options: freshman, sophomore, junior, and senior. All you can do is count up how many you have of each. Now, even if you gave numerical values to these things, right? So freshman is the first year of college. So maybe you could code freshman as 1, sophomore as 2, junior as 3, senior as 4. And I see this all the time. People do that, and then they take the average of all those numbers and then say, oh yeah, so on average, our students are, at 2.5. So, 2.5 years through college. No, it doesn't work that way. You can't do that. You can't take averages of qualitative data. So don't do it, damn it. And you can only do cross tabulations with this qualitative data where you have frequency counts of this kind of stuff. This data would have a time frame for it. What do you mean by a time frame, Kenya?
What I mean by time frame is that there are times during the academic year when some freshmen actually move up to becoming sophomores.
Great
And so
point.
And also there's some semesters when you may live on campus or off campus. So having a time frame for when this data is being collected and analyzed will help in terms of whatever determinations you may come up with later on.
Absolutely. Yeah, that's a good point, because this is the type of data that would absolutely change over time. It would be very, very vital that you would report to the reader when this data was collected, because it is a snapshot of time. Yeah, great point. Absolutely. Okay, standard deviation, which is our first and our most widely known and widely used measure of dispersion, right? So we have measure of center, measure of dispersion, sometimes called measure of width, measure of range, but usually measure of dispersion is the most common term. And it basically just says that. How is your data dispersed? How is it spread out? Oh, that's what the other one is. Measure of spread is another common term for it. So a standard deviation just tells you how wide your data is spread out. Here on the left is a data set with a small standard deviation. On the right is one with a larger standard deviation. It just means how much variability do you have between the numbers. Does everybody report a similar number, or are they all over the place, right? If they're all over the place, you're going to get a wider, larger standard deviation. And if they're all relatively similar, you're going to get a tighter grouping, and you're going to smaller standard deviation. Some examples of these, right? A small standard deviation would happen when you look at the price of the same model of new cars. Because when we say the same model, like you look at all 2021 Mustangs, right? Sure, there's going to be a lot of variability in options, but the prices of, you know, the low end Mustang to the high end Mustang is still going to be relatively similar. I mean, sure, they could be $10,000 apart, but when you're talking about $10,000 on an average price of 60,000, it's not a huge spread. It'd be a lot bigger if you looked at the price of all two-door coupes, right? Then now you're all over the place. So you get a much bigger spread on that. You would have a fairly small standard deviation if you looked at the heights of 30-year-olds, because by the time we're 30, damn near all of us have stopped growing, right? Somebody might still squeak out a half an inch or, you know, even shrink a little bit, but for the most part, we've standardized our height by the time we're 30. Whereas if you looked at the heights of seventh graders, you know that they're still growing. So those heights are going to be all over the place. You're going to have the kids that had growth spurts. You're going to have the kids who haven't had growth spurts, right? So you're going to get a much bigger spread. So another thing to think about is that the standard deviation doesn't necessarily have a bearing on the size of the data, right? The average height of a 30-year-old is going to be much larger than the average height of a seventh grader, yet the data of seventh graders is going to have a larger standard deviation, even though they're smaller numbers, right? So the size of your data does impact the standard deviation. It does absolutely have an effect on it, but it's not a strict linear effect. So larger numbers don't just by definition have larger standard deviations. And smaller numbers just, you know, by rule of thumb or, you know, whatever, don't always have smaller standard deviations. Okay. When we do have groups with different numbers, like when we were talking about the heights of the seventh graders and the heights of the 30-year-olds, which are going to have relatively, you know, I shouldn't say vastly, but pretty big differences between those two means, those two averages. Well, then it's not really fair to compare apples to oranges. It's not really fair to look at the standard deviation of one set and compare it to the standard deviation of another set, because as I said, the size of the data does have a bearing on the standard deviation. I mean, if you look at how a standard deviation is computed, it's literally the average, well, it's not literally. If you want to kind of conceptualize what a standard deviation is, it's roughly the average distance from the mean of your data values. So you look at all of your data values, and on average, how far are all of those data values from the mean, from the average? And when you compute the standard deviation, you literally take each data value, you subtract the mean from it, so then you get what's called a difference score, basically how far your data value is from the mean. Then you take that difference score and you square it, then you add all those things together, then you divide by how many you have minus 1. So you're pretty much taking an average. It's just you're dividing by n minus 1 instead of n. And then you take a square root, which kind of undoes the square. So you can see that mathematically it doesn't work that way perfectly, but you can see that it kind of ends up giving you the average of those differences, how far they are from the mean. And since the calculations involve the mean of the data set, then the average size of those data values does impact the standard deviation. So it makes it really wrong and inelegant to try and compare standard deviations from two different data sets because of the influence of the size of their data sets. But you can do what's called the coefficient of variation, and what that does is it kind of standardizes standard deviations by taking the standard deviation and dividing it by the mean. And then that gives you something that is more comparable and you can compare it to another data set. The example they give is the idea of the average weight of a mouse versus the average weight of an elephant. Well, because elephants are, huge, they're going to have a much larger standard deviation. Even if their data was clumped all together, you're still going to get a standard deviation, in probably hundreds of pounds. Mice, even if they were way spread out, you're going to get a standard deviation that's in, a percentage of a gram type of thing. In this case, it was 9.3 grams, or I'm sorry, 2.4 grams. And then the average was 9.3. So a standard deviation of 1 ton is a lot bigger than a standard deviation of 2.4 grams. Because if you did, tons into grams, you're talking about thousands of grams type of thing. But once you do the standardization, once you take that standard deviation and divide by the mean, you get an answer of 0.258, which basically tells you that the standard deviation is 25, right? Almost 26% of the mean. And then when you do it with the elephants, you get 0.455. And so their standard deviation was roughly 45, almost 46% of the mean. It gives you a more accurate way of comparing those two. So you can see that the elephants have a standard deviation that is definitely more spread out than the mice. It's almost twice as wide, right? We're going from 26% to 46%. So that's the idea of being able to compare multiple standard deviations. That's what the coefficient of variation does. And like it says here, this is often used in finance to compare returns with variability, with different risks. That's one of the most common uses of it. The coefficient of variation really isn't used that often. It's not one of the more common measurements out there. Here's just another example of it, showing you the formulas and everything, that you're just taking S and dividing it by, this is supposed to be X bar. It's kind of hard to tell, but X bar is the symbol that we use for a sample mean, and then S is the symbol that we use for a sample standard deviation. And then what we normally do, just like I did before when I was talking about those things as being percentages, is you multiply by 100% to get it as a percentage, right? So in the previous example, you would take this and multiply it by 100%. It would become 25.8%. You multiply this by 100 and it become 45.5%. So they're normally reported as percentages rather than the decimals, but we all know that all that means is you move the decimal place twice. All right, that is literally all of the info that we have on our slides from our book. Our book doesn't do a great job of really delving into the nitty-gritty bits and pieces of what we're supposed to learn, but those are the main things. There are more measures of dispersion, and in addition to the standard deviation, of course, is variance, which is just the square of the standard deviation. So when you do all that math where you took the differences and you squared them, then you added them all together, and then you divided by n minus 1. Before you took the square root, that's the variance. And then when you take the square root, that becomes the standard deviation. So those two measurements are highly correlated, obviously. The range, just taking the maximum minus the minimum, that's another measure of dispersion. You can also look at what's called the IQR. The interquartile range is another measure of dispersion. And that's just the difference between your upper and lower quartiles. Your upper quartile is just like the median, only it's the median of the upper half. And the lower quartile is the median of the lower half. So for instance, in this data set, right, we have 1, 2, 3, 4, 5, 6, 7, 8, we've got 9. So again, 7 is our middle, that's our median. And then we have 4 numbers below. So if we look at the middle of those 4 numbers, it would be right in between these 6s, right? So 6 would be our lower quartile, because 6 is a number that has 25% of our data values below it, quartile, quarter. Then if we look at the upper half, right, these 4, it lands right in between there, right? And we get 8.5. 8.5 would be our upper quartile, where we have 75% of our data below it. And if you took 8.5 minus 6, you would have a distance of 2.5. That is the inner quartile range. It's basically the range between your quartiles. That's another measure of dispersion that is often used. And in fact, it's what's used to do box plots. If you've ever heard of making box plots, or what are sometimes called box and whisker plots. If you want more information on all of this stuff, I would recommend just watching my videos. I go through everything in mind-numbing detail, including box plots. So this would basically be a complete lesson on all the measures of center, measures of variation, measures of relative standing, which are percentiles and things like that. And then how to display data. There's a whole thing on the different types of graphs that you could do. And then a thing on how to make modified box plots. So these will walk you through all that stuff if you really want to get into that stuff. But everything you need to know for the homework set, we've already covered. So any questions on any of that stuff that we've covered?
Dr. McBride, not to backtrack, but it was on your last slide on data C. I guess I didn't catch what the mode would be on that one.
So on this one, because we have this 5 sitting here, the mode would actually be 6, 7, 8, and 9.
Okay.
Because all of them have a frequency of 2, which is the
Mhm.
most frequent data value, because we have a frequency of 1 with this 5. Whereas with data set D,
There's none.
exactly, we'd be back to no mode because they all have equal frequency of 2. Yep.
Okay, great. I just want to make sure I knew the difference. Thank
Yeah.
you.
Good question. Anything else? Okay. So I wanted to run you through the stuff here in the slides about SAS, right? It talks about how to load data. So make sure that you've figured out how to load data up into SAS and run things, because you're going to need to do that this week, right? This week, we're actually going to be doing some analyzing of data. So hopefully you've had a chance to put data into SAS. Does anybody have any questions or problems with getting their data uploaded? Okay, good. All right. Once you have your data uploaded, I'm just going to start fresh here. Then it's just a matter of, you can either double click on it or drag it across to bring it over here. And then you have to click on the little running figure. I always call it the running man because I'm a fan of cheesy 80s movies. And then that actually loads the data, right? It runs it. So it puts the data in so you can actually analyze it. Now with our first question here, question 3.1, it gives us some data and it just says, make a pie chart, make a bar chart, and then do a pie chart and a bar chart using percentages in place of dollars, and then ask you which of the 4 charts is more informative. Okay, well, that's really easy. You can see that this data set only has numbers, and then I have one that's 3.1 edit. And I don't know if I gave you guys 3.1 edit or not in the data set. Does anybody know if this one's available or not? All right, well, if it's not, just create it yourself. I think actually I just made the 3.1 data set this one. So I think if you guys opened up 3.1, in fact, I should just go over here and look. Let me look at the data
I don't
set.
think you did. I'm looking and I'm not seeing it.
Data files, week 2. I think what it is 3.1 just looks like this. Yeah, I put the percentages into 3.1 for you already. Okay, so if you uploaded 3.1, your 3.1 is going to look like my 3.1 edit. So let me just get rid of this. Delete this. And then let me rename this one. Get rid of the edit. And now everything's the same. Okay. So now you can see that every time you load stuff over there, it changes the data set it puts it in, right? My first one went into import, my second one went into import 1, and now this one goes into import 2. But if you want to change that, you can always name it whatever you want, right? I mean, you could name it dataset 301. It's unfortunately it won't let you do things like you can't put a dash, right? It tells you those are illegal. You can't put a oh no, we'll let decimals, okay, 3.01. So you could call it that, but then it puts this little n next to it, and it's just not a good idea. Just leave it as import. And then you're fine. But anyhow, run it. Yes, replace it. So this is now my first data set. I always like to click on output data just to make sure I have what I think I have, right? So here's my numbers, here's my programs, here's how much money was spent, and here's the money as percentages. Now, if we want to make a pie chart, we just go to tasks and utilities, and then on tasks, under graph, we have a good old pie chart. Double click on pie chart. Again, you could also grab and drag. I'm just a fan of double clicking. That's how I normally do it. You have to tell it what kind of data set you want to grab. So you come down here and tell it, I want data set import, because that was where I saved it. Then you have to add in your category variable. So we want to make a pie chart on the programs. And then you need to measure the frequency. Now, if we leave this frequency count right here and we run it, as some of you may have already done, look what happens. It's doing, each one of them has a frequency count of 1, even though there was definitely different numbers than 1 for each thing. So what's happening? Why is it giving us frequency counts of 1?
Because it's looking at the programs.
Yeah, exactly. It's basically just looking at the program variable, and it's counting up how many times the word nat.def, right? How many times ss showed up, and they all showed up with a frequency of 1. So it's not intuitive. You know, this program is smart, but it's not intuitive. It doesn't realize that you don't want to just count how many times these numbers show up. You want to compare them to their expenditures. So you have to actually tell it to do that. So instead of frequency count, you come down here and you say, no, you need to measure it on a variable. And then you tell it what variable to use. And that's where you put in the expenditure variable. And for your statistic, you just leave it at sum. That's the default. And if you run that one, then you'll see now that all the little wedges correspond to their expenditures, and it even lists the expenditures under each thing. And then if, of course, if you didn't like, you know, SS instead of social security, you could change your data set. I don't think you can change it here. Yeah, it doesn't look like it'll let me do anything with it, but you could open your data set in Excel. You could write this out as Social Security and then re-upload it, and it would change that name. I thought there was a way to change the name once it was in here. I think you have to do some coding to do that, and of course we don't want to do that for something as silly as a variable name, but it is doable. And then of course for the second part where they want you to do it for percentages, you just choose the percent variable instead and run it that way. And you'll notice that the pie shapes do not change at all. All that changes is these are now listed as percentages instead of numbers. And it should make sense to you guys why the pie chart shapes don't change, because a pie chart is relative frequencies anyway, right? The size of each pie wedge gives you the frequency of that data value relative to the whole, right? So if it was 25% of your data, that pie wedge would be exactly 1/4 or 25% of the entire circle, and so on and so forth. So percentages and frequency counts are going to have the exact same size because it's still reporting the shape of the wedge as that relative frequency, as that percentage. Okay, questions on how to do those graphs? And then of course, it also wants you to do a bar chart, right? So we can just go up here and do a bar chart with the exact same thing. Work import, add the category of program. We need to measure it. Again, if we just left as a frequency count, all of our bars would have a frequency of 1. And instead we need to measure it by the variable, and we have to add in the variable of either expenditure or percent, depending on, which part of the question you're answering. If we run it, there's our bar chart for expenditures. You can see that the numbers here, right, are giving you the actual amount of expenditure. And then if we change this and make it percent, remember this shape. It's going to be in fact, I'll take a picture of it so you don't have to remember it. So here's a little screen grab of it. All right, and now we're going to run it with percentages. And I'll bring my screen grab back. And you go, holy crap, they're exactly the same. Yep, the only thing that changes is instead of the numbers, right? See how these are numbers? We now have percentages. And that's it. Bar charts and pie charts, that easy.
Question, can you
Yes,
show
Bruce.
how you did this, the snippet tool again?
Oh,
for the
well,
screen
if you're on a
grab?
Windows,
I've never done that before.
if you're on a Windows machine, it's called the snipping tool. So if you just go to your little search and search for snip or snipping, it'll come up. And then the snipping tool, you just want to click new. And what it does is you can see how this entire page is kind of grayed out. And you have a little crosshairs. And you just need to stick it on a corner. So you stick it in the upper left or upper right or lower or whatever. You stick it in the corner of whatever you want to snip, right? And then you just draw a box. And then when you let go of the cursor, it takes a picture of whatever's in that box. So if I wanted this, this whole thing to put in my Word document, the first thing I would have to do is make it bigger so I can see the whole thing, right? And then I bring out the snipping tool and go new, and I can snip it like that. And the nice thing about the snipping tool is it's now automatically copied it. So if I bring up a Word document, here's our practice exercises that I gave you guys. And if I go down here and just do Control V for paste, it pastes it right into the document. And I'll show you, I'll zoom out so you can see how it's just sitting there. And then of course it's a picture, so you can take it, you can make it smaller if you wanted to, so it would fit somewhere and that kind of thing. So it's a really easy to use, cool, powerful tool. SAS itself will, you can open it in a new browser. You can download the results as a PDF file. And then I thought there was a way to, it usually has this thing where the word it's not highlighted. Sometimes it'll let you kind of export it to a Word document, but I have to be honest, a lot of those tools up here don't really work really well. It's better to just take a screen grab of whatever you're trying to grab. Yeah, so sometimes it can export to Word and sometimes it doesn't. It just depends on what you ran and what your results are.
Thank you.
Yep.
Appreciate it.
Anytime. Okay. So that's one of the hardest things for students to figure out in this homework set is, just how to do the graphs. So we've gone through that. That's pretty easy. There's one here where they ask you to do 3.4, ask you to do a histogram. And in fact, I put all of this stuff in the PowerPoint here. That if you go down to this, it gives you some notes on some of the problems, right? So in 3.4, you can use the histogram graph analysis, and it shows you all the thing you have to do, where you change the number of bins, blah, blah, blah. But you can also use our coding options if you want to look a lot better. So if we want to do 3.4, first thing we got to do is obviously load the 3.4 data. Is it not 3.4? Is it 3.10? 3.4. Oh, 3.4 is determining the range. Sorry, it should have been those instructions should have been for 3.10. So we load 310, run that. It's now going to be an import 2. Check my data really quick. Yep, it's just states with years. Okay, and then 310, it wants us to create histograms for these things, but it's very specific about what it wants us to do, right? It says, construct relative frequency histogram for the ownership data for the 3 years. And where is the, oh, sorry, here it is. It is 3-4. Sorry, it is determine the range, and then you divide the range by 7, you get the width of this, but we're using the data from 310, I think is why I'm screwed up. No, we're not. Where's my 3-4 data? Huh, my 3-4 data is gone. All right, let me upload my 3-4 data. Data sets, 3-4. All right, upload. Go to Franklin. Go to data sets and upload 3-4. Upload. Well, at least one or more of these files already exist. Where is it?
It looks like it's right there in the
Oh,
middle.
there it is. It's down here. Oh, I didn't put a 0 in front of it. That's why. Okay. Let me rename that so I don't do this again.
I was working on 3-4 and I found like in C, it has to compute the relative frequencies for each of the class levels
Yeah,
and whatnot. So I did that by hand. I just, gridded it out.
sure.
And threw it into Excel. So basically, I mean, that's what you have to do. But I think my question was where something about the.
Well, yes, you can do it in Excel very easily, and you can do it by hand relatively easily. There is no easy way to get technology to do frequency counts or relative frequency counts for bins. Like you can't tell SAS, hey, go in and find all data values between 0.705 and 0.755. You can't do that without doing some fairly complicated if-then loops with coding. And same thing goes for Excel. You can't get Excel to do those kinds of things very easily. So you normally have to do them kind of by hand. But my data set, I believe, has all of it done for you. But if you want to go and do it in Excel, I recommend you do that because it's definitely one of those things where it's a good skill to have. So it's good to practice those kinds of things in Excel. But that being said, if we want to do a histogram for this data, right, we just go to histogram. And then we have to choose our data set, and my 3-4 is an import 3. So I click on here and go down and choose import 3. Then my analysis variable is going to be fluoride, right? And let's just run it without doing anything. This is what you get. It's not bad, but it's not what they ask for, right? Because in the question, they want you to determine the range, which is you got to take the max minus the min. Now, if you want to just do it by observation, figure out what's the maximum in this data set, which is pretty obvious, 1.05, and then you find the minimum. Well, you can see very quickly that something that starts with a 7 is the smallest one, right? You got 7.2, 7.5, right? You look around, you go, okay, 7.2. So 1.05 minus 7.2, really easy. So you can see that 0.33 is your range. Right? Then you divide that by 7 and you get a little bit over 0.5. And when you do that, they say just round and just use 0.05 as your class interval width. And they want you to start with 0.705 as the lower limit for the first interval, because you can see 0.72, right? If we start with a lower limit of 0.705, it will capture the lowest number. You don't normally start your classes on the lowest number. You kind of start at where the lowest number is in the middle of your class width. It really all depends on how many classes you want and how wide you want them to be, right? So you can move things all around. But the bottom line is you just got to make sure that your smallest class is small enough to capture your smallest value, and your largest class is large enough to capture your largest value. And then everything else is really, it's up to you. It's dealer's choice as to what you want to do with it. But if you want to do this and make sure that you have 7 classes, right? Well, obviously the default gave you 5. So if we go to appearance and go to bins and set the number of bins and change it to 7 and now run it, well, you at least get 7 bins, but this one, see, is, you can barely see it. It's really small. There's 1, 2, 3, 4, 5, 6. And again, this one's really small too at 7. This is totally acceptable. If you want to just submit that, that's fine. You've done what the questions asked. But if you want to make it look a lot better, if you just click on the code button and then click on edit, you can see that now it's created something called program 1, and it's just copied your code. And the reason why I like doing this is because it tells me, you know, where my data is. It's already there for me. But now I can go to my SAS how-to guide and come down here for week 2, and you can see here's the code for finding multiple modes when you need it. Here's talking about cross tabulations and how to get that out of the menus. And then here's your graphs, right? So here's where you can control the bin width, and you could try this code. And then here's how you can create stem and leaf plots. And then here's an even better histogram that one of my students came up with a while ago. So if we just copy this, literally just copy this, you know, highlight it and do Control C, come over to SAS Studio. And what I do is I like to just kind of put it right here. This is my code. And you'll notice that there's always going to be a proc statement. This is procedure. This stuff at the top, this is, you know, just giving you a title, histogram of fluoride, and a second title. And then the procedure, it's going to run the univariate procedure, and then it has to run it on a certain data. And the code puts it on import 3, and you can see that my data is also stored in import 3. But let's say my data was in import 2, then all you got to do is come up here and, you know, delete this and put in a 2, and then it's going to run it on import 2. So that's really the only thing you have to worry about, is make sure that your data thing is the same name as where your data is. Then everything else doesn't need to change, because your variable is already called fluoride, and then it's going to do all this stuff that's going to make it look better. And then what I'm going to do is I'm just going to delete this because I no longer need this. And so now this is, oh, I don't think I need this either. This is old. Yeah. All right, so now this is what we need. And now if we run this, this is the univariate procedure. It does all sorts of analyses that you don't care about, just a bunch of extra crap you don't need. Here's those quantiles, which is the same thing as quartiles. And then here is the much better looking, looks like it's flipping us off, doesn't it? Histogram with 7.
That's a good one, yeah.
Doesn't it? It could just, every time I look at that, I'm like, oh man, the data is pissed off at us. So this is a really pretty graph that a woman, young lady actually, a couple terms ago, was able to do this. And I was very impressed with her, spending the time, right, to play around with the code. And she basically just found, it's a pretty easy bunch of code, right? She just found this endpoints option where you tell it what you want the endpoints to be. So you give it the minimum and the maximum, and then you tell it by what. So it goes up by 0.05 each time. And then she just put in these labels, which are nice. And then she designated what the vertical axis should be and the vertical scale should be, which basically just, you know, changes what these things look like, your scales. But I thought this was beautiful. It was really well done. So that's why I put the code in there. So if you want to, you know, get the fancy one, then you get the fancy one by just copying and pasting some pretty basic code. Okay, and the rest of this stuff is pretty basic. Does anybody has anybody worked on the homework and has any questions on the homework tonight? Otherwise, you can obviously ask them on Thursday.
Dr. M, one quick question. You stated something about mode. There's a little variation. It'll only, basically SAS and other programs will only recognize the first one, but there was a way to kind of get around that a little bit.
Yes. And in Excel, it's you want to run something called multiple mode or mode.multi. So if you're going to do any of your analysis in Excel, which is totally fine, then you just have to do the function equals mode.multi for multiple modes. If you want to run it in SAS, the only way to get multiple modes is to literally do code. And here's the code: ODS select modes, and then run that, and it'll give you when your data has multiple modes. So the data set that has the modes question is 324. All right, so if we load the 324 data, 324, run that, it's an import 4. Okay, so now if we go to test and utilities, we go to statistics, we go to summary statistics, we run it on import 4. The analysis variable is going to be the rate, I think. And then let's run that and see what we get. Yeah, so there's mean, standard deviation, min, max. Okay, so obviously I need to change my options. I think they wanted you to do the mean, the standard deviation, the median, and I think they wanted the mode. I think that's all they wanted. Okay, so we run that. And that's not right. I want it's the wrong data. Oh, it's by group. That's what we want. So get rid of this one. There we go. That's not right either. All right. This is what happens when you're in a hurry. Okay. 324, complete set of 30 measurements. 324. All right. So let's go to 324 and look at my data. Group, city, rate. Oh, that's right. I got to do it by group. Damn it. Okay, that's my problem. Okay, so summary statistics. I want to look at rate, but I need to classify it. I need to classify it by group. That's what I'm forgetting. And if you run that, then there's your, so group 1, there's your mean, standard deviation, median, and no mode. Group 2, right, there's the mode. Group 3, there's the mode. But these two groups actually have multiple modes, but it's only reporting the smallest from each group. So what you would have to do is go to your code again, hit edit, and then go here, copy this stuff, and then go back here, and you can even put it down below if you want. Put it down here. Make sure that your data is picking up the right thing. It's supposed to be an import 4. So I'm going to change that to import 4, right? And then now I can get rid of all this, because really all I did was keep that around so I know where my data is. And now if I run this, you'll see a big difference. This one still has no mode, but this one has 2 modes. So now you can see both modes, 1.55 and 1.57, and this one has 0.7. If you go back here and look at the output here, it just told you 1.55 and 0.7, but you can see it had 155 and 157, and then this one was only 0.7. So this one just had multiple modes. And then it also wants you to run summary statistics on the entire group, or sorry, all the data, which means you just have to get rid of your grouping variable. So if we get rid of the grouping variable and run it, so now here is the mean and median, and then the mode again of just 0.7 for the whole group as a whole. But as we saw here, this number showed up twice, this number showed up twice, and this number showed up twice. So wouldn't all 3 of them be a mode, right? And to get it to do that, you would have to also put in this code here, which does the exact same thing, which you'll notice that it just doesn't have the class in there. It just says variable rate, and it doesn't have the class. Oh, forgot the run down here. Let me get rid of a line so it doesn't line break. Okay. And then if we put that in here, and just like before, we got to change this to 4 so it's picking up the right data set. And it's the exact same code. It just doesn't give you a class, right? It took away the group class, and it's just going to run the data all together. And if you run this, you'll get all the results together all in one output, right? So here's group 1, group 2, group 3, and then here's everything put together, and you can see that you have 3 modes because they all show up twice. That's basically what you have to do for that one. All right, questions on that? Okay, we're going to end here. And if you have any more homework questions, like I said, bring them Thursday. And that's all we do Thursday is all Q&A. And I'll basically A all your Qs. Okay.
Thank you.
Yep.
Thank
Good night,
you.
everybody.